Hey everybody, welcome back to the shop. Got another viewer project right here. This comes to us from Jeff. He resides up in the Brunswick, Georgia area. And about a year ago, he said he bought a 1943 Lodge Shipley Lathe. 20-inch is the size, so it's the same size as our American pacemaker here. And this is a bolt that goes on the side of the carriage that actually holds the threading dial on. And it got broke. I've just got it super glued together just so that I can hold it and have one piece, and I have two separate pieces there. But you can see the crack right there, it goes all the way through. And what he said happened was that he had this on there and he was cranking the carriage down. Apparently there's a toolbox or something in the way and this got jammed up against it. He didn't realize it and it actually broke it off. And that's what the problem is right there. And he reached out and showed me this and said, would you be willing to make one of these for me? And I said, sure, that's easy enough. Send it on down. We'll make you one and we'll get some video of it, share with our viewers there. So with this being cracked and broken off the way it is, that makes me think that this might have been made out of cast iron. That's what it looks like, is that the way that it was cracked is probably cast iron. A lot of those old machine tools had parts that were cast and then they later machined it to fit. So I don't know if that's what this is, but that's just what it looks like to me. Usually when it's a steel, they'll usually kind of bend before they just crack off like that and break. But anyway, we've got a piece of 3/4 inch stress proof there. This should be 1144 stress proof, free machining, easy to cut, and we'll just make a new one out of that. So we'll go over to the Precision Matthews manual lathe to do all of our lathe work. And then what we're gonna do is go over to our KBC mill and we'll set up, I don't know, either a collet block or maybe our simple indexing head and mill those 6 flats on there for the hex. So as far as sizes go, I believe this end's 3/8. So you got a 3/8 16 thread. This is a 1/2 inch journal here. This is gonna be where the threading dial actually slides on. And you got a 5/8 hex there in the center. This is a 9/16 a journal there, but I don't think this is actually, there's nothing here, okay? And then this is a 7/16 thread there, so you got a 7/16 14. And the way this works is that the side of the carriage, this just screws in, this is sticking out, your threading dial slides up on this, you have a washer and a nut, these are the original. So you have a threading dial there, and these older ones are made where they just kind of pivot there on this journal. So if you're not actually using the lead screw for cutting threads, you can loosen this nut and just kind of let it fall away. At the bottom is your little worm gear, and then you would push that against your lead screw, tighten this nut up, so that whenever you're cutting your threads, your threading dial is right here that's spinning because of that worm gear connected to the lead screw. So simple enough part to make. Should be pretty simple. So we'll go ahead and go over to our lathe and get started on it. Went ahead and just cut us a piece off that we need in the bandsaw. I've done some measuring here. I think what we'll do is just stick it out about 2.5. This is the side we're gonna go ahead and take care of the threads and the shoulder length. So if we go past that hex, so about 2.5, I think that'll work good there. So we'll face it, put a center in there to support it. We'll use our live center and then we'll do our turning. All right, so we're gonna do this thread here first. So that's with the calipers, that's measuring 0.575 to that shoulder. And then so we'll turn that, and then we're gonna turn this next shoulder, and that one is 1 7/16 to the hex there. So turn this one first, then we'll turn that one to size. So you can see the, let's see, right on that tip right there, that tool is starting to try to rub the center. So I've got a different center. I'll go ahead and take the written center out. We've got a small tip in there just to do this thread on the end. Yeah, even the old small trusty center isn't going to work either. It's just not enough there. So, all right, I think what we'll do, I'm just going to eliminate the center for now. And I think we got enough support there. We can go ahead and finish that journal. And then when we go to thread that, we'll put the center back in there. We'll put the center back in when we go to turn the rest of this here too. But I think we can finish off that diameter without the center in there. One last cut of 39 thousandths. Face up. All right, should be there. So I'm looking for about a 370 thousandths diameter here for our 3/8 threads. Let's see what we got. Is it gonna focus? No, it ain't, but it looks like we've got 370.5. So where we need to be. Get our zero set for the next shoulder. So we're gonna go ahead and do a negative 1.432. And that'll take us to our zero. This journal here is 1/2 inch, but we're going to be shooting for 0.499. That's what the original part's measuring. So we've got 50 thousandths to come off of that. All right, let's measure it for our final cut. I just took half of that there, so about 25 thousandths. It should leave us 25 to come off, and it does. So we got really 25.5 to bring it down to our size. Do one more measurement. Yep, 25 thou, that'd be good. That'll give us about a 1/2 thou to polish. All right, let's see where we landed on our size here. 499 is our target finish, and I am at 499.5. I know you can't really see it on that very well, but so that gives us about a 1/2 thousandths that we can just kind of polish this journal down. We got our two journals finished. We're going to go ahead and turn this area here down. This is going to be where our hex is, and if you measure across the corners, it measures 715 thou. So we'll Just turn it down to match. Just go right up to the chuck jaws there, just eyeballing it. Ten thousandths. All right, that should be all for the turning. Give it a check here. It should be on size 715. We're there. So now we'll go ahead and set up a radius tool. We're going to cut an undercut here for the threads, and I'm going to go ahead and put a radius on this corner too. Grab this and show you what we're talking about. So the factory that made this, they just used like a grooving tool to make an undercut there, and that should be so that whatever's sliding on here can go all the way up to the shoulder and then pull up right there without hitting any kind of radius in the corner. But we'll just use a radius tool to relieve that. Start with our thread relief. We're going to take that about 85 thousandths deep. Just get the touch off so we can establish a zero. All right, and we should be able to fix this. All right, let's try that again, see if it stays there. Yeah. All right, so you can see that line there. We're just going to come up to the shoulder and just blend that together. For some reason, the camera does not want to stay focused today. I'm just going to back this up just a touch. Give myself a little extra room for the threading tool there. Make it about an 1/8 inch wide. Just make sure that that corner's cleaned up. All right, that looks good. Now we'll come to this corner. Let's give ourselves a little thread, or well, just an undercut. And that last undercut there, I took about 50 thousandths. That's a 3/32 radius tool that we're using there on the width. Now we swapped over to our threading insert. Let's put a chamfer on there. I've got that kicked around on a little bit of an angle. Looks pretty good. And while we're at it, we're just going to break these corners. Back here. And we'll go ahead and start our threading for our 3/8/16. We'll get our touch off established. Got my cross slide on 0. We're going to touch the tool with the compound here. All right. We'll make a scratch pass and verify our pitch. Bringing this back to 0. Come in there with our screw pitch gauge on 16 and verify it. So that looks good to go. It's lined up on 16. All right, so we're going to be going in approximately 46 to 48 thousandths on our compound end feed. We'll go ahead and start. Since we're cutting a 16 pitch thread, we can line up any position on this dial. That's because 16 is divisible by 4 threads per inch is what the lead screw is there. So it doesn't even, I don't even have to look at it. So we'll just do it by feel, let it engage. Just taking about 10 on the dial at a time. That being stress-proof material, it's not a big deal if you're not using cutting oil. You can cut it without it, but we will go ahead and use a little bit of our dark cutting oil here. Back it down to 5. I'm running the speed that I am because it's just a little easier for you guys to kind of see everything and what's going on. So we're getting close to our depth there. We're at 40, what I say, 46 to 48. So let's go 44. Just like that. We'll come in here, we'll come back to our 0, engage it and make a spring pass. You see it didn't really cut anything, and we'll go ahead and check it right there. Here I've got a go no-go gauge for 3/8/16. We'll just use this today. All right, we still got a little bit to come out of there, so take another couple passes. I'll go ahead and take one at a time on the dial here. That was 1,000, so let's do that one more time. All right, we'll check it again with our pitch gauge, our no-go gauge. Still tight, still got a little more to go. Let's take a couple more thousandths. All right, see how that looks. I think we hit it that time. It's actually still getting a little bit snug on there, so this could stand to have another pass really made across it. But before we do that, what I'll do, since the go gauge is actually screwing on there, let's try the nut that's gonna fit on it and see if it screws on, because if it fits good, there's no reason to take it down any further. All right, here's the nut that is actually going onto the part. You see it fits on there beautifully. Nope, got a little tight there at the end. That's what it did on the other piece, because this nut it's just kind of pushed over there on this side a little bit, so it's making it tight. But you can see we've got a good fit on that thread there. So I think I want to leave it alone. It's got a good machinist fit. We'll leave it right where it's at. We just need to do a little polishing on it. I'm going to use some of this chlor-free degreaser here to clean the cutting oil off. Just take a mill smooth file that last thread, because it leaves like a little burr on there, real sharp. Just touch the top, touch that corner right there. It feels good. And we're going to take some Scotch-Brite here and polish this. Make everything nice, soft and smooth. All of your sharp edges, it kind of blends them over so it doesn't have any kind sharpness or burr sticking out. Go ahead and hit that hex area. But this is it right here. This should be good to go. Blow the dust off. And I'm going to go ahead and measure this journal one more time and see if we took a few tenths off of it. Yeah, so we're at 499 and 2/10. So that should be good. 499, 3/10 right there. So you got 1/10 difference all the way down the length of that. So that should be good. I think this side is ready. Again, the threading dial, the part that you guys saw me using over here earlier, this is what's going to slide on here, and then just hold it on with a washer and a nut on that side. So this side is finished. We'll go ahead and take it out of the chuck. We'll go ahead and take it out of the chuck, flip it around, and finish out the other side, okay? We've got the part flipped around. I've already got it faced off to the 4-inch length, and I thought I would show you something that I went ahead and worked on in between now and that last segment. Went ahead and made a drawing. So I had a training session set up for this morning with Kevin over at mechanicaladvantage.com. As I always say, we get together every week and work on some projects. It's just to help continue my education using CAD and CAM. In this case, I just wanted this to be another little simple practice session, drawing this bolt in Fusion and then creating a print that you can print out and bring out here to the shop to use for your references. Really didn't need this. I was just using it as another training exercise is what I did. But every time I work on stuff like this, it helps me that much more the next time that I go back into Fusion to do some training and do some drawing. So thought this would be a great practice session right here. I know this is not like perfect in any way, but it's good enough for what it is that I'm trying to put on a print to represent. You can see our part right there. Looks good. You know, we have our end view there, which shows the size of the hex. And then we have our shoulder links up here on this. I do have the thread sizes there called out for each end of the thread, 7/16 and 3/8. And then as far as the undercut diameters that I'm putting in the threads, I decided to go ahead and use these details here. So we got detail A and B that just shows the diameter of your thread relief, your undercut there. All right. And that was just to eliminate trying to jumble up more dimensions up here on this actual piece there. So I added the logo there. That was the first time I did that. I think that looks pretty cool. And it's for the Lodge and Shipley Lathe. So anyway, wanted to share that with you. So just a fun little training exercise that we worked on. And now we are back on the lathe and we'll finish this other side with our 7/16 thread and our 9/16 journal there, okay? Our next shoulder length is 750 thou, negative 0.745. There we go. So we're working on this 9/16 journal. This one isn't critical on the diameter that it needs to be at because nothing sits on it. It's just sort of like a spacer. But we're gonna nail it though. So I'm just using my calculator behind us. We're at 0.650. Subtract 0.562 is 88 thousandths. So we're just gonna dial in 88, make a pass. All right, we're looking for 562 on our micrometer. And what did we hit? Looks like we hit 561.5. So I actually took it down about a half a thousandths from what I was shooting for. Not bad at all. Actually, it's a little bit bigger on that measurement there. So let me just read the tenths here and see what we landed on. So we're at 0.5615. 561.5. So yeah, half a thou under. Nothing wrong with that. Like I said, nothing actually fits on this. It's just a spacer. So up next, we've got to put a thread relief in here. That'll be the next step, and then thread it, and then it'll pretty much be finished up. All right, let's get our gearbox set up. So we're looking right here in the inch column. We want 14. We're cutting a 7/16 14 UNC. So there's 14 LBT8V. So L, where are we at? This is how I do it. B, so here's your B, A, B, C. All right, T, we got RST, and it should be V over here. V, and then here's your number 1 through 8. So we're going to be all the way down to the right side. So 14 LBT8V, LBT8V. Should be good. We'll make our scratch pass and make sure we're cutting 14 threads per inch. We got our 14 leaf. That looks good to me. Lined up good. So we're cutting a 14 pitch, which is not divisible by 4. But on this threading dial for this lathe, cutting 4 threads per inch, if you're cutting an even number thread, you can engage the half nut here on any of these lines. So there's 8 lines total. 1 through 4, then you have the half division, so basically 8 divisions. So when we're cutting this 14 pitch, what you want to do is line up on any one of the graduated lines here, okay? So we can line on that one. I'm looking up here, it's lined up with it. Come back here, hit the 1, it's lined up with it. We'll go to this 2.5, tool's lined up. Now, I just got the tool off of the part just a little ways, but so you have these positions in between the numbers and the lines. That's your, what I call any position. So if you're cutting a 16, you can just engage anywhere you want. Like you don't have to look, you just kind of feel it and push down and engage like that, no matter where it's at. But if we did the halfway point right here and I stop it, the the tool, let me get you up here so you can see it. Your threading tool is actually in between the scratch pass that we made there. So whenever we're threading, even number, you can engage on any one of these 8 lines right here. All right, so that's what we're going to be hitting when we make our threading passes. So we'll figure our thread depth. Remember, I cut my threads at 30-degree compound end feed. So 0.75 divided by 14 is 53.5 thousandths. That's going to be your approximate. So it's going to be a few thou plus or minus, just depending on the profile of your insert and how it's shaped. But easy little trick is just take that and just write it right there on your compound, so you don't have to keep looking at your calculator. And we've already taken 2. So I imagine this is going to be probably around 55 thousandths total end feed on this dial once we get it to our proper depth. First pass was 15, this is 10. Just go back off to do 10 thou end feeds this time. Now we'll back off and do 5. This will put us at 50 thousandths here. So we're looking for 53.5. So let's go ahead and bring that back to 0. Let's go ahead and go to 53, make a cut. All right, we're going to go ahead and check our pitch diameter and see where we're at on our depth. I'm going to be using Granddad's thread triangles here to measure the pitch diameter. I have a chart that goes with these that tells you what you should be miking over the triangles. In this case, we're going to be shooting for around 729 thousandths for our pitch diameter. These are a little tricky to use, but they work good once you get used to it. And right now I'm measuring 0.735, so we've got about 5-6 thousandths to come off of it. Remember, this material that we're cutting is 1144 stress proof. It's free machining, and you don't necessarily have to use cutting oil on it. I'm sure I'm going to have a lot of people asking, why aren't you using cutting oil? You should be using cutting oil. The answer is you don't have to. And I'm just trying to keep it clean for me here. Just got to get those triangles squared up. You can feel it when you get it right. Just like that right there. So we are at 730.5. So we've got about a 1.5 thousandths we need to come off that thread. So a couple more little light passes and we'll have that guy ready to go. That's probably all we need right there. All right, let's see if we hit our target. Get it squared up. Feels pretty good right about there. 729 1/10. We hit our target. We're right on what we want to be. All right, we just need to do a little bit of filing here on that last thread. Wants to always kind of leave a burr. First thread wants to leave a little bit of a burr. Just use one of these little mill smooth files. Just lightly go across the top to remove any burrs off of that. We'll hit that corner and we'll grab our Scotch-Brite. You can usually tell if you just very lightly touch it with your finger on whether it's got a burr still on there. Just give it a polish. That softens up all of the sharp edges there and makes them nice and soft on the touch. Polish up that journal there, and that is it. Our lathe work is now completed on our threading dial bolt. So from here, we're going to go ahead and take it out of the lathe, and we'll go to our KBC mill and get it set up so that we can mill the 6 flats on there. Once the flats are on there, that piece will be finished up. Okay, we're set up on our KBC mill. Going to be using this Vertex simple spacer to index it to cut our 6 flats. And we're running this tongue alloy, tongue force rec 3/4 shank. And what we're going to do is just go ahead and remeasure this journal that we're going to be cutting. I'll machine that to 715. All right, so I got my calculator. We want 0.715 minus 0.625. That's our target. Equals 90 thousandths divided by 2 is 45 thousandths. So we'll just be able to touch that off and move the knee up 45 thousandths, and that should make our 5/8 flats. Just bring our cutter down very close. Lock that in. Turn it on, and we'll just go ahead and get it touched off. There we go. Touching there, so we'll set our 0. Said 45. I'm going to go up 44. All right, I think we're ready to cut. I think I want to go ahead and just bring it. We're going to come from the back and just go across it. I've got everything set here. You know, I'm using a ER40 collet chuck, and it's got a pretty good size nut on there, so you just have to be careful of your clearances, but we're good right there. So what we'll do is go ahead and check it. So we're on 0, so we can rotate it around to 180. Let's see where we're at. Looks like we are dead on 625. 2/10 over. Nothing wrong with that. We're just going to leave it right where it's at. Let's just start right there. Go ahead and go another 60. $60. 120. That should be it. Give it a check with our 5/8 wrench. Looks good. That is going to wrap up this threading dial bolts for the Lodge Shipley lathe. Looks pretty close to the original there, minus the crack and the bend that was in this one right here. And I actually think that the finishes look a little bit nicer than the original there. I added the thread relief here on the 3/8 side. That's something that I just like doing whenever I'm machining my parts on the lathe. If it doesn't hurt to have it in the part, I always recommend putting it in there because it actually looks nicer, and it gives it a stronger corner there versus just the thread coming up and then, you know, retracting out to a square shoulder. So I think it actually cleans up the parts whenever you do the radius undercut. And that was the other aspect, you know, use a radius tool. That's why I love using these carbide inserts right here, these profiling tools. They do such a good job of doing things like that, and they make them look so much nicer. Got a nice thread relief on that end for our 7/16, and of course that shoulder right there where the threading dial comes up and stops against that shoulder. Got a nice thread relief there versus whenever they made this, they used a simple grooving tool to undercut that to remove any radius that was in the tool that turned that to that shoulder. So I just think it makes a nice, just a nicer looking part there altogether. So I think Jeff will be happy with this. He's going to be excited to get it back and get back on his Lodge Shipley lathe restoration that he's doing. And I think that's going to wrap this job up. The drawing here, this was another really good training activity that I worked with Kevin on. He's always helping me with this kind of stuff. Every week we love getting on there and just discussing projects and things coming up and whatever we got to work on, and implementing some of these little jobs like this that I don't necessarily plan on going to a CNC for. I want to do it here on the manual, but I still want to be able to go into Fusion and design, draw a part, convert it to a drawing like this, and be able to print it out and have something nice to look at when we're out here in the shop. I'm just always trying to improve my skills and what I can do around here in the shop. So that was a fun activity right there. So that's going to wrap up our Lodge Shipley bolt. I'm going to go ahead and get this packaged up and get it sent out there to Jeff. And I hope you guys enjoyed the project. I always try to show a few things that might be helpful for everybody that's learning. Try to get some nice shots of the threading action over here on the lathe to share with you guys. And I just hope you enjoyed. So hopefully I'll see you here on the next project. All right, see you then.